This question's in degrees. We haven't done a question in degrees for a while. You're solving this equation. It has sine in it. When you've solved sine equations and cosine equations before, you try to get the sine by itself. So if I combine some like terms, so if I subtract 5 on both sides, subtract 2 sine x on both sides, can you see that I'll get 2 equals 2 sine x? And to get the sine by itself, I divide both sides by 2. Sine x equal to 1. Does that ever happen on your pie plate? Yes. What angle? In degrees. 90 degrees. Now, this is what you're going to do naturally. You're going to naturally think of your unit circle, and you're going to solve it between 0 and 360 or 0 and 2 pi. Once you're done doing that, though, I need you to make sure that you look back and say, what domain were they asking for? Were they asking between 0 and 360? No. They were asking between 0 and negative 360 and 0. So if you think about, we said it was 90 degrees, but they're looking in this direction, so this answer won't be in our solution. Our solution will be what? Negative 270. Good. So it says first solve it in that domain, so our answer is negative 270, and then write the general solution. So for our general solution, what do we do for our general solution? We find all of our answers between 0 and 360 degrees, so that's just 90 degrees. Add 360 degrees times k, where k belongs to the integers. Yes? So the domain that's here says negative 360 to 0, which is basically you're looking once around in the negative direction. We know that our answer was 90, but 90 isn't between negative 360 and 0, so then I'm finding this red one here. What angle would that be? Negative 270. So that's why the answer is negative 270. Yes? So the reason in the general solution I used the 90 was if you would go back into your notes in what we sort of set up as our steps for the general solution. In the steps, step 1 was solve between 0 and 360, and then add 2k pi, or in this case, 360 times k, to those answers. Would it be wrong if I used negative 270 instead here? No. Because basically what we're doing when we write this is we're writing all the coterminal angles with whatever value we put here. So if I put 90 there, negative 270 is included in that because that's one of the coterminal angles. If I started with negative 270, then adding 360 once would include 90. And so this first angle that's here in the circle part, it can be anything as long as it starts there. And then the 360k includes all of the other ones. But generally what we wrote down in our steps is that we would put down whatever answers were between 0 and 2 pi, or 0 and 360, and add 2k pi, or 360 degrees times k, to those ones. So I'm just trying to keep with what I said before, but both of those would be right. And you'll find sometimes in your textbook, whatever answer they got, they just use that one and write the coterminal with that, and both are fine. Part B, we got a multi-revolution question. Should try that again. You guys sounded so excited. Part B, we had a multi-revolution question. Perfect. Excellent. Okay, so how do we do a multi-revolution question? Well, if for this one, I think I mentioned to you yesterday that I would show you a shortcut for the multi-revolution question. So I'm going to do that now. Okay, or Friday. Yeah, we didn't have class yesterday. So this is the shortcut for solving a general solution with a multi-revolution question. Shortcut for our general solution. And the way the shortcut works is similar to what we've been doing all the time, is imagining if this was a general solution and that was just theta, what would you do? Well, you would say, oh, okay, is cos of theta ever equal to -1 on our unit circle? Yes. Where? At pi. So you would say theta equals pi, and that's the only one from 0 to 2 pi, and then you have to add 2k pi to that to write all the coterminal ones with pi, because it could be at pi and 3 pi and 5 pi and 7 pi and so on. And so this is how you would write it. But it's not theta, right? What do I have instead of theta? 3x. So if I started the same way and said I was just doing a general solution, then I would have 3x would equal pi plus 2k pi, and so on. If I wanted to solve for x, I would have to divide by 3. But now when I'm dividing by 3, to divide everything by 3, except for this part here is just telling you what k belongs to. It's not actually part of the math. But you'll get pi over 3 plus 2k pi over 3. And this is your final answer. Okay? That is the shortcut. So let's review the long cut. I don't know if that's the right word. There's a shortcut, there's a long cut?
Long stretch, yeah.
Okay, the long stretch. You're not even cutting something.
Exactly.
The long taping back together. Okay, we'll just leave it. What did we do before? Well, if we had cos 3x equals -1, before we solved first between 0 and 2 pi, so 3x would be between 0 and 6 pi. Again, where is cos equal to -1? You already said at pi. That's the first time around. With 6 pi, you would have to go 2 more times around. So second time around, you would get to 3 pi. The third time around, 5 pi. Hello? So on the third time around, you'd hit 5 pi. So if 3x equals pi, 3 pi, and 5 pi, then x is going to equal pi over 3 pi over 3, which just simplifies to pi, and 5 pi over 3. So in the long way, you first solve between 0 and 2 pi, and then you write the general solution by taking each of those answers and add 2k pi to them. Obviously, this answer is bigger, it's clunkier, it's not quite as elegant as the first answer, but would be considered both perfectly correct. And so if you like always doing the same thing, then maybe you like the second way because it's the same as we did yesterday. Yes?
How did we get those first 3x equals pi, 3 pi, and 5 pi?
We got that 3x equals pi, 3 pi, and 5 pi because we asked ourselves when was cos -1. So on our pi plate, when is the x coordinate -1? That happens at pi, only at pi on the first time around. But since we have a 3x, if 1x is between 0 and 2 pi, then 3x's would be between 0 and 6 pi, which is like 3 times around. So on the first time around pi, second time around, this would be 3 pi, Third time around, this would be 5 pi. So graphically, well, or looking on your unit circle, would you agree pi over 3 is about there? Pi is right here. 5 pi over 3 is right there. Okay? In this second solution, it says take pi over 3 and do all the ones coterminal with pi over 3. Take pi, do all the ones coterminal with pi. Take 5 pi over 3, do all the ones coterminal with 5 pi over 3. And you would get all the answers that end in those 3 spaces. In the shortcut, we got as our answer pi over 3, which is this one. And then instead of having to go 2k pi, which is full times around, this one noticed that the space in between these are equally spaced by a third of the time around. So 2k pi divided by 3 means that you're jumping like this. And you would still get them all. But you are hopping only a third around each time. And it would still list all the coterminal ones. Yes?
Does this always only work if only do like equal spaces?
This one only works if you're equal spaces, but anytime you have a multi-revolution question, it will work because of the way the compression works, the spaces will be equal. Okay? Sometimes you'll still get 2 answers. Like, notice in this one, cos is only equal to -1 at one spot, right? But had I had this same question and used -1/2 instead of -1, when is cos equal to -1/2? Pi over 3 family, but quadrants 2 and 3. And then you would get 2 answers with plus 2k pi over 3. Now, after the general solution, this question says also find all the ones that are answers within -2 pi and 0. So I actually find that our diagram here, -2 pi and 0 is once around in the negative direction, so we'll need to find this one, and that angle. So if we wanted to list those 3, what would they be? -pi over 3, -pi, and -5 pi over 3. Questions for practice? Four, 8, and 9.